Well, folks, we're back.
Hey, you know what? This is the next to last lesson
Of the year. Wow. That's amazing.
One more after this?
Just 2 more podcasts total.
Woohoo!
So today we want to talk about organic chemistry.
Organic chemistry. Is that like organic food?
No.
No. Why do they have the same name?
Well, see, organic means that it comes from a living thing. It's really carbon compounds. And so we're going to just kind of get going with some carbon compounds today.
So organic food is something completely different. We're just talking about stuff with carbon.
Correct.
Okay.
All right, so that's what we're going to do.
Good distinction.
Let's dive into it. So organic and nuclear chemistry. We're just going to do organic today. That's the first lesson. This is podcast 21.1, organic chemistry. Objectives here, alkanes, alkenes, alkynes. You don't know what this means yet, but you will. All right, so what's a hydrocarbon, Mr. Sam?
Hydrocarbon has hydrogen and carbon. Hence the name.
Yeah, hydrocarbon. They're chemicals that have just hydrogen and carbon. You use hydrocarbons all the time. Examples of hydrocarbon include methane, ethane, propane, butane, pentane, hexane. Hey.
They all end in ane.
Yeah,
and they're all alkanes.
Okay, here's an important. They're called alkanes. They end in an A-N-E, and we have some numbers here, or some terms. And it's actually important to know what meth, eth, prop, bute, etc. mean. So let's kind of walk ourselves through that. You need to know that if you've got one carbon, it has the prefix meth. If it's got 2, it's eth. 3 is prop, and bute. Now, the way to memorize, those are the ones that are hard for me to memorize. And so my elephant, you know what he does?
He picks boogers?
No, he plays basketball.
Oh, okay.
Which is silly too.
Yeah,
my elephant,
I have a 3-year-old.
Yes, my elephant plays basketball. Methyl, ethyl, propyl, butyl. You got to memorize those. And then after that, pent for 5, like a pentagon. I'm pretty good with that. You know the pentagon. Hex sounds like 6 if you know your prefixes. Hept, Olympic heptathlon, 7. Octopus have 8, right? Nana is 9. Kind of sounds like 9. And deca, like decade. The decade, or decathlon. So you do have to know these prefixes. That's kind of the important thing.
Yeah.
And then the A and E just tells you that it's just got hydrogens and actually nothing but single bonds. All right. Now, there is also something called isomerism.
Yes.
Or isomerism.
Yes.
Or isomerism. All right. So if we have pentane, now pentane is just carbon bonded. And how many carbons would there be if it's pentane?
5. Pentane, pentagon.
So I've got 5 carbons, and so I would have hydrogens on the outsides of this.
Now we're going to draw all the hydrogens here for now, but
we're going to get lazy.
We're going to get lazy
fast.
here real soon, and we're going to stop drawing the hydrogens. The idea, guys, is once you get all the carbons, you make them all have 4 bonds with hydrogens after you've gotten everything else put on.
So this is called pentane.
Yep.
But there's also another variety of pentane that you can have. If you were to draw this 1, 2, 3, 4. I could put another carbon right there.
Right, still 5 carbons.
5 carbons.
Still 12 hydrogens.
And if you were to do the hydrogens, I could draw a line where these would each go.
9, 10, 11, 12. Look at that.
So that is an isomer of pentane.
It is.
Now, could I draw another one?
You could.
I could draw this one, right? 1, 2, 3, 4, and 5, like that.
Well, that's just like the one you just drew.
Well, no, it isn't. It's the carbon.
Exactly like the one you just drew.
Why?
Because it's flipped.
Yeah, you just flipped this one. So that one doesn't count.
No.
All right, so that's not truly an isomer. But you could do this one, though, guys. All right, and this one is also an isomer of pentane. It's the exact same thing. Isomer, basically, what is an isomer?
It's has the same chemical formula with a different shape, different orientation of the atoms.
Same formula, different
structure.
Structure, actually, is there. These are actually different chemicals with different properties.
Yep. And
we'll learn a little bit later how to name them. All right, actually, which one is right now?
It's later.
It is later. You number the longest chain of hydrocarbons. Make branches have the lowest possible numbers. You have this. Identify the branches. Name the longest chain. All right, so let's do one.
Yeah. Now the trick here, guys, is actually finding the longest chain. Sometimes it's not in a straight line.
So if I were to look at, in this case, the longest chain is actually right here, because that's number 1, number 2, number 3, and number 4. And then I've got a branch here and a branch here. So his last name will be 4. My elephant plays a basketball, so his last name is butane. I should start with the back first.
Yeah.
And then I'm going to say that I have, on carbon number 2, I have a 1 carbon branch,
Yep.
and on carbon number 2 up another 1 carbon branch.
Right.
So we're going to say 2, 2 di. Now it's a 1 carbon branch. Methyl butane.
All right. Now, why didn't you start numbering from the other carbon, where you have the numbers 1, 2, 3,
Yeah.
4? Why didn't you?
You could
number
also
the other
go
way?
1, 2, 3, 4, but the rule said, if you look at the rules, you want to have the lowest numbers possible, lowest possible numbers, and a 2, of course, is smaller than 3.
All right.
So that's how you do it. How about this one right here?
Okay.
Longest chain would be here, 1, 2, 3, 4. This is very similar to that last
It
one.
is.
So this is going to be also a butane.
Mm-hmm.
There's only 1 branch,
Yep.
and it's a methyl group having 1
on
carbon.
number 2.
So it'll be 2 methyl butane.
Alrighty.
Not hard. All right, now this one's a little more complex. Got to find that longest chain.
Yep.
All right, still
4.
1,
Yep.
2, 3, 4. So his last name is butane,
Still.
and this will be just 2, 3 di. By the way, I say di because there's 2
There's
methyl
2
groups.
methyl groups. Yep.
Dimethyl. If you had 3 of them, it'd be trimethyl or whatever. You could also have ethyl groups and such like that. I don't know if we've got examples of that. We'll find out.
Probably.
Oh, here's some groups that gives you some ideas. A methyl group here. This would be an ethyl branch.
Yep.
This is a propyl branch. This is an isopropyl branch. Notice there's a little
Yeah, it bonds to the middle
bonds to
carbon
the
on
middle of the
propyl.
group. Yeah. And this is a butyl group, which
Yep.
is 4. A sect butyl, when it bonds to the second one in the butyl. Isobutyl, notice it comes off, this is where the regular chemical is, and this is called a tert butyl. You don't really need to know this for the AP test.
Probably not. Yeah.
All right.
All right.
We also have things called alkenes and alkynes, and alkenes have at least 1
Double bond.
double bond.
So alkanes are all single bonds. Alkenes have a double bond,
And
and
this has-
alkynes have a triple bond.
You know, what we should say also is that the formula for alkenes, by and large, is CnH2n.
N. 2N. Sorry.
And then alkynes is CnH2n minus 2. And
Yep.
while we're at it, alkanes are
Alkanes.
2n plus 2.
Right.
Let's actually flip back to that. This alkanes have a formula of CnH2n plus 2, where n is the number of carbons.
Yep. Now, if they form a ring, it's a whole other
Yeah, they're
ball of
rings
wax, but they're just
straight.
straight, then you're
Ish,
fine.
yeah. All right, when you name an alkene, you basically follow the same set of rules, except we essentially need to number where the double bond or the triple bond is, and we have to also indicate what number it's on, and we use instead of an A and E ending, we use the E and E ending or the Y and E button.
Yep.
All right,
Let's do a
so
few.
let's do a few.
All right.
There are 4 carbons.
Right.
So 1, 2, 3, 4. Now I'm going to number it this way because I want the double bond to have the lowest possible number.
Yep.
So his is going to be, there's 4 again, butene. The E and E says it's got a double bond, and I'm actually going to say 1 butene because at carbon number 1, it's between 1 and 2. You get the lowest number possible.
Yep.
Is the double bond. So 1 butene looks like that.
Okay.
All right, what about this one? Now notice we've got the triple bond. Now I'm going to number this, of course, 1.
No.
No, what's wrong?
Number from the
Yeah,
end.
I want the numbers to be the lowest. 3, 4, 5, 6. If there's 6, this will be hexyne. The Y and E denotes the triple bond, and since it's after carbon number 1, it's just 1 hexyne.
Hexyne.
Hexyne. There you go. Like your hiney or whatever. Okay, here we have with a branch. So this has got a double bond, but we're going to start on this side because we actually want the double bond to have the lowest number. 1, 2, 3, 4. And actually, I could jump up here. It would actually be the same answer.
Yep.
Wouldn't it? So there are 5. So his last name would be hex
Nope.
5. Sorry, pentene. And this is going to be actually a 1 pentene, and then I've got a branch. This branch right here. He's on carbon number 4, so he's going to have 4
methyl.
methyl 1 pentene.
Yep.
Now we do have this one up here too. I just realized I saw that just a minute ago. This has got triple bonds. We'll number them 1, 2, 3, 4. So this will be a butene because it's got the triple bonds. So this will be, it's at carbon 1 and carbon 3, 2 of them though. So
Yep.
be 1, 3. What would it be, Mr. Sams?
Yeah, 1,3 butane.
Did you say dibutane?
Dibutane?
I think it's dibutane.
Yes, we do.
1, 3 dibutane. You should
Yep.
smoosh
Put
these
those
together. Okay. And then this one has a double bond here. So 1, 2, 3, 4. So this will be a butene, the E and E for the double bond, and it's on number 1. And then I need to then specify my methyl group right here. So this is a 2 methyl 2 butene.
1 butene. That's a 1.
Oh, that's a 1.
Can't read your own handwriting.
Can't read my own handwriting.
I have that problem a lot.
All right, one more, I think.
Yep.
1, 2, 3, 4, 5. So this will be a butine. No.
Nope.
Yeah, pentine. And it's a 2-pentine, and it's a 4-methyl 2-pentine.
Yep.
Good. All right.
Alrighty.
Hey, isomerism is not just this different structure, but you can also have a structure that is related to what's called cis and trans.
Yeah, this happens when you have a double bond.
Or just double.
Just double bond on 2 carbons that are not at the very end. So this will never happen on a 1-butene. It would only happen on a 2-butene.
So this is butene right here, but it's 2-butene. They're both 2 butenes.
Yep.
But because of the orientation, this carbon and this carbon are on the top, if you will. Yep. And these carbons, one's on top and one's on bottom.
And the way I remember this, the cis starts with a C and it's shaped like a C.
Oh yeah, like this.
Like a C, yeah.
I always remembered trans because it looks like you're transporting a long direction.
Oh, yeah, that works too.
Yeah. So trans, basically opposite, cis on the same side.
Yep.
So they're actually, those are both 2 butenes, but they're different chemicals.
Yep.
And you can see down here pictorially what they look like.
Yeah.
All right. We're not going to do more examples.
Nope.
All right. There also is some odd things here we call aromatic groups. There's a chemical called a benzene, and this is benzene right here.
Without the double bonds.
Without the double bonds. Technically, you should have alternating double bonds.
Yeah.
It actually has 2 resonance structures. We're not going to get into that. But basically, this is the structure. This is how they draw them.
Yep.
And actually, they've drawn them with the double bonds here.
By the way, guys, when you see compounds drawn like the ones Mr. Bergman just marked up there without any letters on them, anytime there's an angle, that's a carbon.
That's a carbon, 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 that's a carbon.
And then the hydrogens are assumed.
And the hydrogens are branching off of there. And you can see, actually, this is what it looks like right here. And then, actually, benzene is such an important chemical in the chemical world, they actually just put a circle in it, and that equals that right there.
Yep.
All right. And so if you have aromatic groups, if we're trying to name something here, actually, if you put 2 benzene rings, it's called naphthalene. If you put 3 of them, it's anthracene. If you put 3 of them together, but they're not in a row kind of deal, they're kind of at this angle deal, it's this one. And then this is a more complex one.
Yep.
All right, so if I want to name something, and we can put things on them like bromo groups, those are just bromo, it's like a group, you would just say, 1,4 dibromobenzene. You can just kind of figure it out.
Yeah,
this is methyl benzene. That makes sense.
Also called toluene.
Yeah.
Common name.
And then this has got this group right here is important too. So it's toluene. So this is a chlorotoluene. It's on number 3, where this is number 1 and number 2 and number 3. I think you get the idea.
Yeah.
All right. Well, how would we name this right here? This is an interesting.
Oh, that's a fun compound.
This is a very fun compound because it's got the benzene ring with the CH3 at the top.
That's a toluene.
This right here is a toluene, so this is going to end in toluene. Ene, by the way, because it has double bonds. And then we have nitrogen at 3 different places.
So
actually, it's at question number 2, 3. This is number 1 here. 1, 2, 3, 4, 5, 6.
We call it 2, 2, 4.
2, 2, 4, 6.
Oh yeah.
Trinitro toluene. Nitro toluene. T&D. This is what they blow things up with.
Kaboom.
Kaboom. Yeah. All right. Hey, functional groups. We could talk about some different types of groups. Now that we've assumed that everything's basically made of carbons and hydrogens. But
that's the backbone that all these are built off of.
Right. And so if we have a hydrocarbon that has a halocarbon, pardon me, that means it's going to have a halogen, which is fluorine, chlorine, bromine, or iodine. And then we just use some prefix like fluoro, chloro, bromo, and iodo. Iodo! I like that name.
Sounds Italian.
Yes, it does. And if you end in an OH, it's an alcohol. It'll have this structure, ROH. If it's an ether, it's this. And by the way, the R, what's the R, Mr. Sam?
It's just any carbon chain.
Yeah, a bunch of carbons connected to whatever.
Yeah,
some
it could be one
here.
carbon, it could be 100 of them.
Yeah, exactly. An aldehyde has got a double bond and a single bond to an H. They look like this, where R is that kind of the radical, is actually what it's called.
So guys, by the way, have this table out when you're doing your homework.
Yeah.
You'll get real familiar with these really fast.
Ketones have got a double bond and then some carbon things.
It's the
on each.
aldehyde cousin. Instead of the hydrogen, they have another carbon
Yeah,
chain.
ketones, they smell pretty good, usually. Carboxylic acids, actually, most of the acids that we have studied, like acetic acid here, is actually one of these.
Acid, yeah.
Esters and the amines, and you can kind of see this. It's basically, you're going to see as we do an example. All right, what type of a chemical? We're not going to name it. What type of chemical?
We've got an OH there. That's an alcohol.
If it ends in an OH, so you have this chart here, right? Oh, you see OH. It's an alcohol.
Sometimes called a hydroxyl functional group.
Yep. This one has a double bond O. And then an H, and then a bunch of carbons. This is your R right here.
That's the R.
So what's that?
That's an aldehyde.
That's an aldehyde. On the homework, you're basically just going to identify these types.
Yep. Got another aldehyde.
And that would also be an aldehyde. All right, now this one I've got an OH group, and that's it. So that's an alcohol. All right.
Ooh, that's a special group, and that wasn't on the chart.
Then let's skip it. Okay, right. But this one is an easy one.
That is, yep.
Actually, this is ethanoic acid. It's got 2 carbons.
Yep.
My elephant. This is ethanoic acid, better known as acetic acid.
That's your
double
vinegar.
bond O, OH. Yeah, that's
It's
vinegar.
a carboxylic acid.
It's got a double bond O and an OH. This is the carboxylic acid group. So you're looking for everything that is not C's and H's.
Yep.
This one,
COOH. We need to talk about that.
We should talk about it. If you see COOH, that actually means this.
So that's another carboxylic acid.
This is also an acid, yeah. All right, now this one has a double bond O and then OC da-da-da, like that. Which one's that?
That's an ester.
Yeah, this is an ester. Look at the chart. Go back to this chart, wherever it is.
Right there. Second one from the bottom.
Second one from the bottom. You see this guy right here. So that was the ester.
Another ester.
And that's another ester. And that's it.
And that's it.
All right, that is the second last podcast of the year.
All you need to know how to do, guys, is name alkanes and identify functional groups. The end. One more podcast, and it's done.
Hallelujah! Woo!